CPVT panel he studied is formed by two longitudinal aluminum bases, each one with water channels. In each of these aluminum bases, there are 4 arrays of solar cells, in the top and also in bottom. To concentrate the radiation in bottom cells, 2 highly reflecting concentrators are attached. Finally, a glass layer and an external framework closes the panel. Each string is divided in arrays of 8, 11, 11 and finally 8 solar cells, where each group of solar cell has a bypass diode in parallel. The 2 top strings are connected in series, and its positive and negative terminals are placed here. The bottom strings are also connected in series, and its terminals are in here. See that outer terminals are for the top cells and the inner ones are for the bottom cells. 2 projectors of 400 watts will be the radiation source in this experiment. Okay, now to start the experiment, start by connecting the top string into a variable load resistance and also an auxiliary resistance to measure the voltage and current of the CPVT panel. With only a group of 8 solar cells uncovered, start by measuring the irradiance in each solar cell and then swipe the resistance from its maximum to its minimum value to see the current voltage curve of 8 cells in the oscilloscope. Remember that you need to use the XY format in the oscilloscope. Repeat the same steps now for the bottom cells. Proceed by changing the position of the projectors from point A to B and then to C. Please be careful with the projectors. The projectors will be too hot and you need to use gloves to handle them. Okay, now you can safely change the direction of the projector. Adjust its direction to the solar cells. And repeat the previous steps to see the influence of the CPVT tilt in the energy production. Finally, remove the cover of the panel and repeat the previous steps with all the panel uncovered. You need to do the experiments for the top and also for the bottom cells. The only difference is when you are measuring the irradiance, search only for the 3 minimum values and for the 2 maximum values. Record the cell number where they occur. You will see now that the current voltage curve has a step-like behavior due to the several bypass diodes and the non-uniform illumination along the panel. To finish this laboratory, connect the top and bottom strings to an inverter with a max power point tracking system. Connections are made in one side to the top cells and the other side of the inverter to the bottom cells. Measure the voltage and the current in the top and bottom cells and check if the results are accordingly to the ones that you previously obtained and that are in the maximum power point. And that's it for today. See you next time.